So we've talked about two different levels of measurement so far. We've talked about nominal, the nominal level of measurement, and we've talked about the ordinal level of measurement. The next one up from there is what's called the interval level of measurement, or you could refer to using an interval type scale in your research. So with an interval scale, what we have is we have a set of ordered, a set or series of ordered and equal intervals. And this is where it gets the name interval from, because we have this idea of equal intervals. This may sound complicated, but I think you already have a lot of experience with this in your everyday life. It should be very intuitive. For example, if I can make an interval scale here that you'll be quite familiar with, and let's just divide it up like this. The idea here is that we have a set of ordered intervals. So each of these is an interval, right? And they're ordered in the sense that we can number them. So this could be 0 or 1, 2, 3. I'm actually going to make this, I will start. I'll do 0. I'm going to make this a temperature scale. So this will be 0 degrees Celsius. This will be 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius. A temperature scale like Celsius or Fahrenheit, specifically Celsius and Fahrenheit. We'll talk about another temperature scale in a minute, but Celsius and Fahrenheit temperature scales are examples of interval scales because we have these ordered equal intervals. And the important thing here is we have information here that we didn't have in an ordinal scale. So first of all, we have all of the information from an ordinal scale. For example, if we are comparing 1 degree to 2 degrees, we know that there is a difference. So we can tell that there is a numerical or quantitative difference. We know that, just like we did with an ordinal scale. And just like we knew with an ordinal scale, we also know the direction of the difference. So we know that one thing is different from the other in terms of how much there is, and we know the direction of that difference. For example, we know that 2 degrees Celsius is a higher temperature. There's more temperature than 1 degree Celsius. There's more, it's a hotter temperature. So we know the difference, we know that there is a difference, and we know the direction of the difference. What we also know that we didn't know in an ordinal scale is we know the amount. So we know that 2 degrees Celsius is exactly 1 degree more than 1 degree Celsius. And 3 degrees Celsius is exactly 1 degree more than 2. And that is because these are exactly equal intervals. So hopefully an interval scale is pretty intuitive. What I think is not intuitive about an interval scale is what I'm going to tell you next, which is that an interval scale, wrong color. An interval scale does not have a true zero. The way that your textbook puts this is they say that it has an arbitrary zero. Now, what I mean by a true zero is, and sometimes this is also called an absolute zero, what I mean is that there is an absence of whatever it is that we're measuring. So in our example that we've been talking about, we're talking about the Celsius temperature scale. So if this right here, if this were a true zero, that would indicate absence of temperature. There would be nothing colder than that. But we know that's not true because when we talk about Celsius and also Fahrenheit, we talk about negative temperatures. So we know this scale continues to go over down here to the left, and we start getting -1 degrees, -2 degrees. So this cannot be a true zero. This cannot indicate an absence of any kind of temperature. Instead, what this indicates on the Celsius scale, this indicates the freezing point of water. This is the freezing point. So why this matters is because there is a certain thing you cannot do with an interval scale. With measurements taken with an interval scale, you cannot make what we might call ratio comparisons. Comparisons in terms of ratios. So ratios are things like where we say, oh, it's a 2-to-1 ratio, or it's a 7-to-2 ratio. Whoops, 7-to-2 ratio. Also fractions. Fractions are really ratios. If we have something like 1/2. So when we talk about not being able to make ratio comparisons, here's what we mean. If I were to take 1 degree Celsius and 2 degrees Celsius, and I pull these out over here, what kinds of statements can I make about these? Well, what about, could I say 2 degrees Celsius is twice as hot as 1 degree Celsius? And I encourage you to pause the video and think about this for a minute to see if you can figure out what the answer to that is. And I've kind of already given away the answer in terms of yes or no, whether this is a valid statement, but I encourage you to think about why. So hopefully you've taken a minute to think about that. The answer is this is not a valid statement with the Celsius temperature scale because it's an interval scale. So we cannot say this. And I'll try to show you why. If I were to have the Celsius temperature scale and we were to zoom out on it, so we're going to zoom out far more than we do. This is the same thing as up here, but I'm just going to zoom out. So here's the part that we already see. So if this is 0 degrees, and this is 1 degree, and this is 2 degrees, and this is 3 degrees. So this is already the part we have. But then it continues down here into -1 degree, -2 degrees, and so on until we get to let's see, it's -273.15 degrees Celsius, all the way down at the bottom. And that is as cold as you can go because that is the absolute absence of temperature. So when we ask this question about 2 degrees Celsius, we're saying, is 2 degrees Celsius twice as hot as 1 degree Celsius? This 0 here, it fakes us out because we interpret this, we think this is saying, is this distance from 0 to 2 degrees Celsius, is that twice this distance? And it looks like the answer when we phrase it in those terms is yes. That is twice the one distance is twice the distance of the other. We're making a comparison in terms of ratio, and it seems valid. But because this is an arbitrary 0, this is not twice the temperature of 1 degree Celsius, because 1 degree Celsius is actually this much temperature. And 2 degrees Celsius is actually this much temperature. So the actual difference, let me use a different color here so it's clearer. The actual difference in temperature is only 1 degree Celsius, but we're talking about spanning this entire distance here. So that is why you cannot make comparisons in terms of ratios with an interval scale. Now, I'm running out of space here and also out of time, but I'm going to try to cram in a quick description of the last scale because it's almost exactly the same as intervals, so I need almost no space to talk about this. The last type of scale is called a ratio scale. This is the last of our 4 levels of measurement. And the ratio scale is exactly the same as an interval scale in the sense that you have a set of ordered equal intervals. So it's got this, right? You are able to tell that there is a difference between different numbers on the scale. You can tell the direction of the difference. You can tell the amount of the difference. It is exactly the same as an interval level of measurement. The only difference is this right here, because a ratio scale does have a true 0. And an example of this, well, there are lots of examples. If you get on your bathroom scale to see how much you weigh, that is a ratio level of measurement, because if you step off of it again and there's no weight, there is a complete absence of weight on the scale, then the scale drops to 0. So that is a true correct 0 because it indicates the absence of what it is you're measuring. A ruler, also, a 0 on a ruler indicates an absence of length. So that also makes sense in terms of it being a true 0. If we want to make a comparison with the Celsius temperature scale, there's another temperature scale called the Kelvin temperature scale. And on the Kelvin temperature scale, 0 Kelvin is an absence of temperature, an absence of any molecular motion. There's no heat going on there. So that is an example of a ratio scale. And in that case, you could say something like 1 Kelvin is 1/2 of 2 Kelvin. Or to go with the same kind of statement I made before, we could say 2 Kelvin is twice, I don't want to confuse you, twice 1 Kelvin. That is a valid statement because it is a ratio scale. It has a true 0, which means I'm completely out of room here, but I'm going to say you can make ratio comparisons, and that is why it is called a ratio scale.